And I'm Angelica Gonzalez, and I'm a product manager for parting and grooving. And this morning I am with Fredrik.
Yes, and my name is Fredrik Selin, and I work as a product application manager for our parting and grooving tools.
As I said, we are sending live here from our headquarters in Sandviken. And with no further ado, let's start. Well, today we will talk about parting off, how to make successfully parting off operations. We will go through two different cases for deep pocketing and conventional versus Y-axis. We will give some recommendations and give some success cases. The first customer or the customer job, it's kind of one of those customers that want to make the shift to Corrugated QD, that have a medium size to a large scale production volume. They probably have a lathe with a bar feeder and internal coolant. And of course, the idea is to have more unmanned production, more predictable and more stable process. So in this case, we will part off a bar of 60 millimeters in a stainless steel of 316L.
Yes.
So probably this customer have been in contact with one of our yellow codes, and they got to know that Corrugated QD is the most reliable system for parting off for deep grooves and also in different other applications. So let's have a look in our website what we can offer.
Yes.
So if you go to our website, the idea how to find Corrugated QD. Let's see if this. Sorry. So you go to tools, the parting and grooving tools, parting off tools, and here you will have first recommendations of different systems that you could use. Of course, Corrugated QD it's the first choice for parting off and deep grooving. And so here, Corrugated QD features a high precision coolant with the plug and play system to increase the chip control and increase tool life. And what it means is really that it will translate to be able to have a higher cutting data and get more productivity without having a limitation in the edge line security. So in Corrugated QD, we have a wide assortment of grades and geometries for parting off. And you can use QD for parting off bars of above 38 millimeters. And also taking into account the material economics, within Corrugated QD systems, you can find ultra thin inserts and blades so that there is no material waste in this specific application of parting off, which is critical in the last steps of the machining process. Of course, you can also have QD for deep grooves for those optimal cuts for when Corrugated 1.2 it's not it doesn't reach, so you can use Corrugated QD. We have also the parting off blades that we will see in action during our demos, the Y-axis blades that you have here. So essentially twisting 90 degrees from the original conventional parting off blades. We also have the SL heads that will provide more accessibility and flexibility for different adapters in the machines. QS shanks and the switch tools really optimize for sliding head machines and the turning centers. But Fredrik, let's have a look a little bit about geometries and grades.
Yes, we have quite a big assortment when it comes to inserts in Corrugated QD, and when it comes to geometries, we have 5 different geometries for only parting off. And we will see 2 of them in a demo later. So we will have a closer look for CM, that is our medium feed parting off geometry, and also CR, that is our high feed geometry. We can not only part off with QD, we also have turning geometries, grooving geometries, and we also have a profiling geometry that we also will have a look at later in this live event. And some of the inserts also have wiper to provide a really good surface when you part off. When it comes to grades, we have 3D PVD grades, where 1125 is our first choice. And we also have CVD grades, 3 different. And recently we introduced 4425, that is our high performance steel grade, also in QD, so you can part off steel with incredible long tool life, I would say.
The second generation in biotechnology in there.
That's true.
So after that, you can also get some more suggestions on tips on technical aspects, how to apply the tool, and of course also a little more in-depth recommendations on the grades and geometries here.
Yeah, so here we have different applications and different material groups, and every combination have their own first choice recommendations. So if we start with this one, I will say we will come really close to a really good solution for the application and material.
So now that we know a little bit more what we can do and what we can find in Corrugated QD, I think we can go and move forward to find out what are the best cutting recommendations. So that you can also do in our website. If you go again for the first step of the menu here, a little bit up, it says get a tool recommendation. So you go there and immediately you connect. Of course, you need to log in first. But once you have been connected, you get access to the Core Plus tool guide. And let's have a look how we can then find the better tool and the cutting recommendations for this operation.
Yes, and if we go into tool guide, we can switch and choose what application we will use. And in this case, we will part of a bar. So that is what we will choose. And here we will start with choosing the material. And as Angelica said in the beginning, we will use 316L in this demonstration. And this material database is really huge, so the easiest way is to search for the material and then click on it when it appears. Next step is to choose your machine, and here you can put in what kind of coupling interface you have in your machine, so you get good tool recommendation that fit your machine. And you can also what kind of coolant you're using, and in this case we use internal coolants. I exclude others, and in this you can add all your machines in your workshop. And when it comes to the diameter, it was 60 millimeter, and then we can also put in the workpiece material cost to optimize the application or the tool recommendation from a cost perspective. So we put in that, and when we have finished everything, then we click on get results, and then it will think a little bit, and after a short time it will come up a solution that is a parting off blade with internal coolant, insert with CM geometry, and here we have the cutting data recommendations, the cutting speed and the feed. And as you can see here, there are 2 different steps in this operation. If you have a more advanced operation, you can have even more steps. But in this case, we have 2 steps. So there is 1 feed rate towards the center, and then we're really close to center. We would reduce the feed to improve the tool life. And here you can get even more details about the RPM and the cutting power that is required for the operation. So that is how we get the recommendation. And if we summarize the recommendation, it looks like that we have, if we go forward, Angelica, thank you. The recommendation we got from Tool Guide is that we will use a 3 millimeter CM geometry in 1125. And that is one of our CM is the medium recommended parting off geometry that it works for most materials and applications. And 1125 is our universal grade that is working really well in both steel and stainless. And here we will go for a cutting speed of 169 meters per minute, which is, I would say, quite high, but this grade can handle it really well. And a feed rate of 0.1, that is our recommendation to start with. So with that said, I will hand over to Marcus out in our center. So please, Marcus.
Welcome to station number 3. My name is Marcus Edström, and I'm a technician here at the Coromant Center in Sandviken. And during this machine demonstration, we will be using this DMG Mori NLX 2500. So let's start the demonstration.
So here we have the parting off operation. We have an entry ship, and then we have good ship control and a stable process with part of the component. Looks really nice. So if we do some recommendations to having a successful parting off, I would say that the most important is that you minimize your overhang. Overhang is really important when it comes to a stable operation. So use the minimized overhang, then you will have a stable process that will give you the possibility to use high feed and also give you good tool life. Next topic for getting a good parting off is the correct center height. And this is important to have a good tool life, especially when parting off to center. And also both the tool life for the insert and the tool actually. So to have a correct center height is very important. And as we saw in the recommendation from Tool Guide, we have to reduce the feeds when we go to center. This will also increase the tool life really much, because we will minimize the pip that will be remaining, and it will save the edge line really much. And also don't feed over center when you reach the center. Stop a little bit before, and then the part will fall off anyway, and you will save tool life only by doing that. When it comes to coolant, we recommend to use both over and under coolant. We would like to use the under coolant to have the good tool life, and the under coolant can reach really close to the cutting edge or the cutting zone to cool the insert. When it comes to over coolant, it will help for chip evacuation and chip control. So the recommendation is to use both. And when it comes to parting off stainless, the built-up edge is one of the biggest challenges, I would say. And here you can play with the cutting data to minimize the built-up edge, but I would say that to choose a grade with a high edge lane toughness would increase the tool life drastically. And here we have our 1145, that is a really good grade for parting off to center when it comes to stainless steel. So, Angelica, let us go through the job again. What happened?
Yes. Well, as usual, our customers, they need to keep up with their production volumes. They want to increase productivity. They are always looking to get this productivity boost, to have this process security, to lower the noise, and of course, reach the CDX and reduce the vibrations. So in Coromant, we are always striving to meet our customers' expectations and also get new innovations.
Yes.
And so this is why if we look at the parting off operation, we all know that it's kind of simple operation. However, it is kind of tricky because it is in the last stages of the machining process, and there's any small detail, and of course the process security is very important, as we will see here in the conventional parting off. Then you see that the forces are always directed towards the edge of the insert, and also in the most weakest point, which means that it is more unstable, that maybe have more vibrations. So how can we make it more stable? So by twisting or tilting the blade 90 degrees, we can see that the forces are now going along or down the blade, which this increased 6 times the stiffness of the blade, translating this into a more stable process, the possibility to have a higher feeds, and of course higher feeds means less cutting time, and therefore more probably with better geometries and optimized grades or hardened grades for wear resistance, then you have a longer tool life. So we see, as we see like a bit of a summary here, y-axis parting, it's actually increasing productivity in our processes. We use this FEM analysis to identify the different forces and the phenomenon that happens during in the tools during operations. And also there is a new trend, or we see more and more multitask machines using the y-axis, giving us a standard feature or a standard, a new thing that it's just there. And also in the turning centers, more lathes are now having standard y-axis. So this also gives us the opportunity to say, okay, if we use the y-axis, we might get benefits for better productivity. And so we did so. And when it comes to the programming, of course, having a new axis in the machining strategy, that means that you need to modify your code. And I'm very sure that our general codes and also in our website, we have different examples of codes that you can use to implement the y-axis method in your machines and in your current processes if you have a machine that has the y-axis. And when it comes to the machining tool builders, we've been cooperating with DMG Mori, developing a tech cycle that will enhance just by pressing a button in the machine, you can actually have the whole code. And so let's see it in action. We have Marcel from Germany in our Coromant Center that will give us a look.
Hello, my name is Marcel. I'm here in the Sandvik Coromant Center in Renningen. Today I want to show you the y-axis parting off on the CTX Gamma 1250 TC on the Siemens control. So now we are directly on the machine in front of the control, and now we are in the shop turn interface. And right now we just selected the normal cutting off cycle, traditional way in X. Now it's very easy and convenient on a DMG machine. You just select the y-axis parting off cycle. Then you come to this screen, change the transformation to on, select the safety distance, and choose the direction in which you want to escape from the component. A small hint from Sandvik Coromant, what you get some cutting data, some recommendations, what you can start with on each material and components. Now we just press OK, change the tool in the cutoff cycle, select the tool. Now we have it on the QDY, and that's basically it. Accept it and press start, then it will part off with the y-axis.
Pretty cool.
Nice. Thank you, Marcel. And with all this new information, we can optimize our process, I would say. So what we will do is that we will do some modification on our stainless steel part that we will part off. We will go for the y-axis, of course. We will change from a 3mm CM to a 3mm CR geometry. That is our high feed geometry. And we will go to 1135 that has been good in stainless, I would say. So this is the recommendation we will go for here. We will lower the cutting speed a bit to 120 meters per minute. This is also something that we have seen with y-axis, that you can lower the cutting speed a little bit, but then you can increase the feed very much. So here we will go from 0.1 in feed to 0.3 in feed. So we will triple the feed, and then we will part off the component really fast. So what we will do is we will take our normal conventional blade, remove it from the adapter, put in the y-axis blade, and then we will use the same QD insert that you use in a conventional blade to the y-axis blade. We use the same key in the y-axis blade, so everything is compatible with each other for conventional and y-axis. So it's only the blade that you change. So with that said, I will hand over to Marcus again out in the center, and he will show us how it looks in the machine.
Welcome back to station number 3. Let's continue with the next demonstration.
We have the same component. So here we come with the y-axis. We're 0.3 in feet. So it goes fast. So, and when it comes to the assortment for our y-axis blades, we have 3 different blades. The 3mm blade that we saw in the demo right now before, where you can part off up to 120mm in diameter with an overhang of 60mm. The same blade we have for 4mm also, but also for 4mm we have an extra long blade that you can have an overhang of 90mm, and then you can part off up to 180mm. So that is really impressive, I would say.
Yes, kind of unique.
Yeah, it is. So to make a summary of this parting off, we can see the conventional blade has a timing cut of 11.5 seconds. When it comes to, if you compare overall, this is really high productivity thanks to the high cutting speed, I would say. It's an easy setup for normal parting off. Everyone has done it for many years. We have the internal coolant that will boost the tool life and help the ship evacuation. When it comes to conventional parting, I would say that the diameter will set the stability. So if you have a large diameter, you need to have a large overhang, and that will set the stability. So in some case, when you have a large diameter, you need to reduce the feeds to be able to have a stable process. But when it comes to the y-axis, if we check the timing cut there, we have 5.5 seconds, and that is really fast. So we have a productivity increase of 110% from starting from really high.
Exactly.
But here, as we said, you need some additional programming. It's not what you're used to maybe, but some machine, we saw the tech cycle from DMG as an example, but it's also possible to program yourself. And if you need help, we have our yellow coats out on the market that can help you.
Exactly.
We have the same internal coolant for both blades, so that will not be any difference, I would say. And the y-axis blades are stable for all diameters, so it more or less doesn't matter if you part off 180 or if you part off 50mm. So it will always be really stable. So let's have a look at them side by side.
Exactly.
Video.
Yes. So here you will see both. Then you have the y-axis to the right side and the conventional on the left side. And essentially you see the speed of the y-axis is 3 times higher than the conventional one. Essentially this means that the timing cut is less, and therefore the material exposure in the tool it's much lower, which will eventually translate into a higher tool life, and also the possibility to use hardened grades, as I said before, to increase the wear resistance. And so here we see the different feed from both conventional parting and the y-axis. So this gives us in a really good position to suggest y-axis parting for all those customers that are looking for higher productivity and process security at the same time in an operational like parting off.
Yeah, and we have actually a success case here.
From our own production,
Yes.
We were producing the Corachak 390. We did 2 different materials, and then you see the big difference in the higher feed. It's 3 times higher, corresponding to the conventional parting off. So a bit on what we have discussed during this morning. So I will say a highlight on recommendation would be kind of reduce the feed rate, isn't it, Fredrik? As something important to take into account.
Yeah.
What else will you recommend?
The recommendations, we can just summarize it. To minimize the overhang is very important. Reduce feed towards center is important, and use internal coolant, I would say. That will give you a lot.
Yes, and of course, if you have a machine with y-axis in in the machine, of course, we will recommend to use the y-axis if you want to increase your productivity. But also, I would like to say that if the standard assortment that you find in our website, it's not fitting your specific needs or specific processes, we can still support you again with our tailor-made assortment that it's also available in Corelcat QD. So let's have a quick look. I mean, if you go into your page of customized solutions in the Coromant, you start customizing, and there you will see the parting and grooving offer, the different product families that are available to customize. Now, in this case, we will choose Corelcat QD. And then here you have the possibility to customize tools and inserts. We will have in the blades, you can select the functional length. You can have shanks, capto, or different SL heads for these applications. And then you move forward in the selection process to select what kind of tool hand you need. So now we will just have a left reinforced and the cutting width that it's along these ranges, and then you can also choose the cutting depth between the range that it's given. Select the type of reinforcement that you will need, if it's a curve, and also the cutting diameter. You can choose between 20 and 500 millimeters. So you will go through the different selection fields. We always recommend to have internal coolant in the tools to increase process security, and also, as I said initially, the functional length of the blade. You can also modify it here in between 99 and 110 millimeters. So once you have chosen everything, please double check that everything is according to what you need, and you press save. Once you press save, what you are doing is creating a quotation that will automatically generate a product code and also some general drawings, initial or preliminary delivery dates, the price for different quantities, and different product data. But also, as Fredrik mentioned before, you also get here the drawings of this customized tool that you can later on go take it, import it into the CAM program, and check in your own process and your own program if it actually fits or if it's actually what you were expecting to before you place an order. So with this, I would like to thank you everyone for your attention. One last recommendation will be to use Corelcat QD in company or in conjunction with the other complementary products that we have, Corelcat QF for dedicated face screwing, and Corelcat QI for the optimal internal grooving and face screwing in small diameters, which is actually one of our latest introductions now in October, together with the 4425 grade. It's kind of new now in the market, and we encourage you to try it. Thank you very much. And now we will have some time for some questions.
Yes, and I have here on my computer, and I think we have one question here. Regarding the tool life, how much higher can you expect the tool life with y-axis parting?
Mm-hmm. Well, I think the tool life depends very much on the type of geometry, the type of grade that you use, and the feed. So probably not big difference, I will say, from the conventional parting off.
No, but what you can do, you can save time in cut, and that is quite. If you have a long time in cut, you will have a lot of wear on the insert. So that's one thing you can save. So I would say that, and you can also use a more wear resistant grade because of the more stable setup. So I would say that the tool life will be better if you optimize it for the y-axis. And then we have one more here. If we compare QCut and QD, what are the main benefits with QD? And I think we have, when we developed QD, we did a lot of things much better, I would say. And if I would point out some things, I would say that the internal coolant is one big thing that will help to increase the tool life. And we have also developed new grades that are in QD, and we have a much higher, let's say, quality of the edge line that will give longer tool life. So I would say, and you can also run much faster with QD than you can.
Exactly, aside of the sterility of Corrugated QD and the accessibility that the thinner blades can give you, that you can also run or part off between the different spindles in the main spindle and the sub spindle.
Yep.
Things that you cannot really reach with the big tools setup, like in QCut.
Exactly. And I think that was it. And there is no more questions at this time. So
thank you very much for your attention, and we will share this recording later on for those interested. And thank you once more.
Thank you.
Bye-bye.
Bye.